folks, welcome back to Physics with Captain Rod. I'm making this one to help you out with number 13 in your homework. So let's see, we have this 1,000 Newton force acting on the system shown. This system of basically boxes, I guess, A, B, and C. Now, a frictional coefficient of 0.25 here is given. And it's not really clear about whether or not that's a static or kinetic, but we'll talk about this here in a little bit. I assume that's a kinetic coefficient of friction. And part A says to find the acceleration of the system. So I probably would start with this. See, how you define your system is critical here. There's all kinds of normals we can talk about. There's a normal here between the ground and mass A. There's a normal here between the ground and B. There's a normal here between the ground and C. Now, in theory, you can kind of add those together and call it one normal upward, depending on what your system is, and I'll get to that here in a minute. There's also normals between these two surfaces, so the normal between A and B, and a normal force between B and C. So there's like 5 different possible normals here we can draw. Now, to get the acceleration of the system, start by defining our system like this. It doesn't matter that that's 3 separate objects. Define your system like that. Draw a free body of it right here. Don't try to put your force vectors in this picture. It'll get too muddled too fast. That's a picture for just understanding the problem, if you will. So just sketch a picture of the system. This 1,000 Newton force is definitely an external force. Now, if we're treating this as one object, we really only need one vertical normal. Even though we have 3 different, like we'll call them littler normals here, we can just kind of group those together and call it one single normal up. Same thing with our mg. We could put 3 separate mg vectors, but we don't need to. We can put one single one down and just use our combined mass. Definitely there's a frictional force to the left on that system. And that frictional force can be, try expressing it like this as 0.25 times the normal. And if you have your free body and you look at it, you should realize that the normal will equal the weight of this object, right? Hopefully, I think what will happen is when you look at your free body and you kind of compare this 1,000 newtons against this, you'll realize this thing's got to be a sliding frictional coefficient. I'm pretty sure that's what I meant when I wrote it. And then to find the acceleration of the system, what you're going to do is write a proper Newton's second law equation in the x direction. So here's what that should look like, right? Write out sum of all forces equals ma. Define right as positive. Your force equation should have 2 terms to it. One to the right, so it's plus, one to the left, so it's negative, and then equals ma. And if we define our system like this mass right here is the total mass of the system, 100 kilograms, it looks like. So now, all right, to find the normal force between A and B. So now what you do is to go back and redefine our system. And we can either define it as A, like this, or this. And it won't really matter, to tell you the truth. I'm just going to kind of pick one to chat about. Let's define our system like this. Then what you would do is you would draw a picture of mass A, and mass A alone. Like draw that maybe like right here. And that should have, let's start talking about force vectors, an mg down where you use mass A only. It should have a vertical normal because of this surface right here. Now that's maybe, you know, if I were writing it, I would call it like normal with an A on it, the normal acting only on A. That 1,000 newtons acts to the right on mass A. And here's a surface right here that's got another normal. And that normal would act to the right on B, right? But it acts to the left on A. You're going to need to get that in there. That's the force that this is talking about, the normal force between A and B. And you also need a frictional force acting only on A. And I'll help you out with this. That frictional force is going to be 0.25 times the normal at this surface. Now, if you look at your free body, right, it should be clear what that normal is. And again, I don't want to give up too much here. And I think I'll just stop. I think I'll leave it at that. That should be enough. Hopefully you can get through this entire... well, I guess let me chat about C just a little bit. Find the force that C applies to the ground. Okay. Draw a free body of just C. It definitely will have a normal to the right, a normal BC I would call it. It also has a frictional force, and it also has a normal at this surface. Now if you think about the question where it says find the normal between C and the ground, there's two of them that I can think of. Or I'm sorry, let me restate it. Find the force between C and the ground. You have a normal force at this surface, which is up on mass C, and it's therefore down on the ground. Then you also have a frictional force on this object, and I'll let you decide on the direction it is on mass C and on the ground. But those are the two forces that the third part of this problem is asking about. So, hope you're enjoying the videos. Have a great day.